1.7 is on something you guys have seen before. The midpoint formula and the distance formula. We saw each of those in Algebra 1. I want to first show you what this means graphically, and then we'll use the formulas to go ahead and solve for each. So first, I want to find the distance and the midpoint of a segment AB here with these two endpoints in the coordinate plane. So don't write anything down. Just sit back and watch how we can look at this in a slightly different way, a more geometric way. So we're going to graph these. I have point -2, 3. There's point A. And then 5, -2. There's point B. All right, so this segment here how to find the midpoint of this segment and the length of the segment. So first, let's go ahead and discuss what a midpoint actually is. The middle point, if I'm looking at a horizontal segment, say something like this, where I have on a number line 5 over here and -2 over here, right? How can I find the middle point of this? Yeah.
You add the 5 and 2 together and divide by 2.
We're going to add 5 and 2 together, right? And divide it by 2. That's not going to give me the midpoint, though, right?
Oh, wait, no. Yeah.
So I get 3.5. Is 3.5 the midpoint? That's the distance from one of the endpoints, right? Does that make sense? So if I go 1, 2, 3.5 here, that will give me the midpoint. So 5 minus 3.5, right? I get 1.5. That's going to be the midpoint of the segment. The spot that is 3.5 from both endpoints. So let's look on here. My x values, 5 and -2, right? Half of this length right here, we decided this length was 7, right? With 3.5. So if I go from one of the sides, 1, 2, 3.5, I go straight up from there. That gives me the x coordinate of my midpoint. That makes sense?
Yeah.
I'm taking this horizontal segment, finding the midpoint of it. I can do the same thing with this one right here. I can use this over here, or I can just use the figure method and count. The length of this segment is 1, 2, 3, 4, 5. Right? So 5 right here. And then half of 5 is 2.5. So I know the midpoint is going to be 2.5 from both sides. And if I go straight across from there, 0.5, that gives me the coordinate of my midpoint, coordinates of my midpoint. Right? So the midpoint of this vertical and horizontal section will give me the x and y coordinates of the midpoint of any diagonal segment. So far, so good. So graphically, how to find a midpoint? Yeah.
Is it the same if you did it like over across the window?
What do you mean over and across the window?
Like from the A and then up. Instead of like drawing a triangle from like down.
Oh, if we did it like this? Yes, that would give us the same results. All right?
It's just 0.5 instead of 0.5.
Because this one, the y, how far is it up on the y? 0.5.
Oh.
So that's our y coordinates. Next, I want to figure out the length of this segment. How long is this segment right here, this magenta one? What type of triangle have I drawn here? Right triangle. Do I have any skills to find the length of the hypotenuse of a right triangle when I have the lengths of 2 of the legs? My Pythagorean theorem. So our distance formula essentially breaks down to our Pythagorean theorem. 5 squared plus 7 squared equals whatever that distance is squared. We called it c squared in our Pythagorean theorem, right? So I have 25 plus 49 equals d squared. D squared equals 74. Square root both sides. D equals 8.3. So that's our distance using Pythagorean theorem. And that's our midpoint using the midpoint of horizontal and vertical lines. Let's see how that's similar when we're using our midpoint and distance formula. Let's start first with our midpoint formula. So let me get rid of this. This is what you should jot down in your notes. So we need to know how to use the midpoint formula, and the midpoint formula is right here. Oh, don't bounce there. So make sure we write down this midpoint formula. And this tells us how to find the midpoint when we're given 2 points without using that coordinate plane. So the first thing we're going to do is see what we're looking at here. We have x and y whenever we're given points. So what we're going to do is take the average of the x coordinates and then the average of the y coordinates, and that will give me the midpoint. So first, put our x coordinates together. -2 plus 5 divided by 2. That'll give me the x coordinate of my midpoint. And then let's put our y coordinates together. 3 plus -2 divided by 2. So I end up with 3 over 2 and 1 over 2. Is that the same thing I found for the midpoint over here? Yeah, right? That's 1.5 and 0.5. Okay. So that's how to find the midpoint using that formula. Questions on that? Yeah. Yes, because we're finding the average, right? We're finding the middle point, so we're going to add them together, divide by 2. That gives me the middle. Next, let's see how we can use our distance formula. We already found the distance was 8.3. Let me go ahead and get rid of these guys. And our distance formula here. So our distance formula, right? Remember I told you it's very similar to the Pythagorean theorem. We can say it's the exact same thing as the Pythagorean theorem, right? So we looked at the Pythagorean theorem, and we had a squared plus b squared equals c squared. With that c, that hypotenuse was the distance between the 2 points. So what I wanted to solve for was this c. So if I rearrange this a wee bit, and if I want to get c all by itself, I'm going to take the square root of both sides. And I get c equals the square root of a squared plus b squared. Notice our distance formula. We have the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. Squaring this, remember when we found the distance between 2 numbers on the number line? We took their difference and then took the absolute value. By squaring it, we don't need to take the absolute value anymore. This will turn out to be the legs of that right triangle I drew. So we should have 5 and 7. Okay. So let's go ahead and plug in our numbers. We have our x's that need to go together and our y's that need to go together, just like in the midpoint formula. So we have d equals square root of negative 2 minus 5 squared plus 3 minus a negative 2 squared. And what do I end up with? D equals the square root of negative 7 squared plus, add the opposite, 5 squared. And I end up with, take this over here, the square root of 84, 49 plus 25. So I'll do it one step further. We have 49 plus 25. And I get the distance between those 2 points as 3. We're going to be taking a lot of square roots in this class using our Pythagorean theorem. We use a calculator on everything in this class. Right? This is not an arithmetic course. All right. Oh, where's on? Let me get rid of all of this rubbish. Oops. I'm still going to use this right here. Like that. That will be. All right, we're all set up. All right, so now I have an endpoint and a midpoint. And I want to find the other endpoint. Let's take a look real quick graphically how we can go ahead and do this. I think visually picturing where this is going to go is probably the best way to look at it. Right? We should have an idea where things are going to be, even without doing any calculations. So I have a midpoint, 2, 4. Let's call that M. And I have an endpoint R, negative 1, 7. I'm going to go ahead and put in that segment. All right. So when just looking at this, we have a midpoint here and an endpoint here of a segment. Do we have a general idea as to where that other endpoint is going to be without calculating? We should have a fairly good idea. Does anyone want to come up and circle where the, come on up. Circle where you think the other endpoint. Don't put exactly, just in the general vicinity.
Just in the general vicinity.
Yeah, give me a little circle. Somewhere over there. That's pretty good, pretty good. Maybe accurate. He knows that if this is one endpoint and this is the midpoint, right, the other endpoint has to be somewhere over here. Right? We can look at this, right, using the magic of Smartboard to find exactly where it is. Right? Because I know if this is the midpoint, this is exactly the same length as the other half of the segment. So if I clone that and I drag that same thing down here and connect the two ends, looks like he was right on, right? That other endpoint should be at 5,1 right here. Okay? Another way, if you don't have the magic of a Smartboard, right, is to go ahead and use that idea of kind of slope, if you will, right? How many do I have to go over and how many do I have to go down? So to get to here, 1, 2, 3, and over 1, 2, 3. The other endpoint has to be that same distance down and the same distance over. Right? So I'm going to go down 1, 2, 3, and over 1, 2, 3, and that gives me that same spot that we're looking for. Algebraically, it looks like this. We know that we have x1 plus x2 divided by 2 equals, we'll say that's x of the midpoint. And I know that y1 plus y2 divided by 2 equals the y for the midpoint. By simply plugging these in and solving for our one unknown variable, we can go ahead and find that other endpoint. So I have my midpoint for the x, so I'm going to plug that in here. And then I have the endpoint for the x, so I'm going to plug that in here. And all I need to do is solve that to find the x-coordinate of my midpoint. So what I'm going to do, multiply both sides by 2. Negative 1 plus x equals 4. Add 1 to both sides. X equals 5. Should be no surprise that we had found 5 for the x-coordinate of our midpoint. And then if I do the same thing for the y-coordinate of the midpoint, right? There is our y-coordinate, so there's our 4 there. There's the other endpoint, and then that y is the endpoint we're looking for. And then go ahead and solve that out for it. Multiply both sides by 2. 7 plus y equals 8. Subtract 7 from both sides. Y equals 1. That's the y-coordinate of my midpoint. So my midpoint here is 5, 1. I hope you understand it graphically like this, right? But we can also calculate the endpoint or the midpoint or the distance formula algebraically as well. And these are a couple of additional parts of this that link back to the idea of angle bisectors that we spoke about in 1.6. So I wanted to give you a couple of problems on those as well. So we have the measure of EFG is 136. Right? So I would trace that. EFG is 136. That whole thing is 136. I want to know what the measure of angle EFH and the measure of angle HFG if FH bisects angle EFG. So what I have to do is, if it bisects, divide it by 2. And what do I get? 68 degrees. Next one, we're given that RQ bisects PRS. So those guys are congruent. Whenever I know that I have a bisector, I know I have 2 congruent angles, I can set those equal to each other. So 3x minus 20 equals x plus 40. Subtract x on both sides. 2x minus 20. Add 20 to both sides. 2x equals 60. Divide both sides by 2. X equals 30. And then I can plug that back in here. 30 plus 40, I get 70 degrees. Since these are congruent, that has to be 70 degrees. And then the measure of angle PRS equals the sum of those two using our angle addition postulate for 140. So again, impressing you with the magic of the smart board, we have a ladder. What the heck? Amazing.
Kind of looks weird.
All right, so we have a 20-foot ladder that is 8 feet from the house. I want to know how far up the house I can reach so I can see if I can paint all the way up. So I have a right angle. What I'm going to do is pull this guy out. I'll go ahead and group those together. And then let's go ahead and blow this up. Again, using our Pythagorean theorem, much like we did earlier today, I have a right triangle, and I have 2 sides and 1 missing side. So I'm going to use my Pythagorean theorem. A squared plus b squared equals c squared. I have one of the legs. I'm going to make that A. This one can be my B. And then the longest side, the hypotenuse, which we know is always across from the right angle, is going to be my C. So 8 squared plus x squared equals 20 squared. 64 plus x squared equals 400. Subtract 64 from both sides. X squared equals 336. And I'm going to take the square root of both sides. Anyone has a calculator can check up on me, but x should equal 18.33 feet.